So for A, we'll calculate first upper and then we'll calculate the lower sum. So here function is given k is the constant number. So what will be the integration of this function? Fx equal to k in interval 0 to 1.
K equal to k.
So now we'll do by upper sum and lower sum. Interval is given 0 to 1. So the first step will do the partition. So I am assuming one partition. So for this remark, there exists a partition. That means for one partition, if both limits are same, that integration will be same. So the same partition will take like previous class, 1 by n, 2 by n, and the last one is 1, that is n by n. So in each interval, we'll calculate maximum and minimum, that maximum value of the function and minimum value of the function, and then we can find the upper sum and lower sum. Since function is constant, so maximum and minimum value both will be the same. So if we calculate the upper sum for the function f corresponding to this partition Pn, it is summation, or we can add 1 by 1 also. So the length of each interval is 1 by n and maximum value is k. Similarly, minimum value is also k and length of each interval is 1 by n. So what will be the upper sum and lower sum? K times, that is the maximum value, into the length of interval, that is 1 by n. So n will run from where to where? So if we see the upper sum, we'll take the maximum value in the interval xi minus 1 to xi and then multiply by the length of the interval. We will get sum. Similarly, for lower sum, we have to take this infimum, that is the minimum in this case. Minimum value or infimum here in this case is k, and then length of the interval, that is 1 by n, because we took equally spaced interval. So what will be, how many interval here? We divided into n equal parts, x0, x1, x2 and xn. So total how many interval here?
N interval.
Yes, total interval. First interval is x0 to x1, another one is x1 to x2, similarly xn minus 1 to xn. So total, because n from, so total here I can count like I from 1 to n, or I can write like first the formula, then here capital Mi, that is the supremum in that interval, and xi minus 1, sorry, xi minus 1, the length of the ith interval. So that is k, and that is 1 by n, I from 1 to n. If you add, what you will get is k by n is constant.
Sir,
and if you add 1 n times, you will get k only. Yes.
Sir, how am I equal to k?
Mi is the supremum of this function f over the interval xi minus 1 to xi. Like each interval you have to find the supremum, and the function is constant, so supremum will also the same number, right?
Yes, sir. Yes, sir. I got it.
Similarly, infimum will also the same number. So now I will calculate L, the lower Riemann sum, that is the infimum in this ith interval, and that is also k. This is 1 by n. So in the both the case will, so as n tends to infinity, because it is constant sequence, it will converge to k. So upper Riemann sum and lower Riemann sum both are converging to k. So the value of this integral will be also k. So this function is integrable, and the integration of this function is k. So this implies that upper Riemann sum, this is also converging to k, and lower Riemann sum, that is also converging to k. So the integration of this function will also k. So now similar to this, we'll do the question number B. Again the same interval is given, 0 to 1, but at 0 the function value is 1, and other point it takes value 0. So the question is, it is integrable or not? If it is integrable, then what will be the integration? So now for that question again we will take the same partition. So I am writing again the function here. It takes value 0 and 1. So open 0, close 1, and at x equal to 0. So if we choose the same partition, what will be the upper Riemann sum in this case? That is summation I from 1 to n, capital Mi. So what will be the maximum value in x0 to x1, or supremum? What will be the supremum from x0 to x1? So first I will write, yes, so I will write this is m0 x1 minus x0, m1 x2 minus x1, and so on. In the last it is mn xn minus xn minus 1. So all this interval length is 1 by n, because this function is 0 in this, from 0 close interval, sorry, open interval 0 to 1. So this function is takes value 0. So all this m1, m2, m3 all will be 0 only, because function is constant 0. In those interval it remains 0, but here the supremum will come 1. So I am putting all those value. So this value is 0, this value all are 0, this value is 1. So what we will get, 1 times the length of this interval is 1 by n. So 1 by n, as n tends to infinity it will goes to 0. Similarly we will calculate the lower Riemann sum. That means it is m0 x1 minus x0, m1 x2 minus x1, and so on. So now we will take the infimum, and in infimum in all cases it is 0 only, all the interval. So this value will come 0, as n tends to infinity it will converge to 0. So this function is integrable, and its integration will come 0. So the value of integration of this function from interval 0 to 1 is 0. So this function is integrable.
Sir, why m0 equal to 1 of person?
Why?
Sir,
In
can you
upper
please
sum, how
Capital M.
once again?
m0 equal to 1?
I am just using the basic definition. I have to find a supremum in each interval, and the length of interval if you multiply, and add all those things, you will get the upper sum. So here length of interval all are equal, that is 1 by n. Now in this interval x0 to x1, what will be the supremum?
So this should be M1, not right? Because
that
XI,
value 1.
this should be
So
M1.
can you please explain once again? I can't understand.
Graph, if you add, so what I do 0 to 1 by n, it is 1 only. Is it okay?
So how M1, M2, these all
Yes,
are
sir.
there.
Yes, sir. The first one should be M1, no, sir.
So because MI XI
okay.
minus XI minus 1.
Okay,
So
okay.
that's
So this is wrong. Yeah, this is 1, this is 2. M1 is 1. So here also the same thing. I wrote the wrong index. M1 and this is M2. Now is it okay? See what is the
Can you
supremum?
please explain once again?
So this UP of this formula, anyone have doubt? First tell me. That I explained in the last class how we are adding. So now in each interval we have to get the length of the interval, that is xi minus 1, and what is the supremum in that interval. So like x0 to x1, x0 is 0, x1 is 1 by n. So 0 to 1 by n, what will be the supremum for this function? And this function at 0 it is taking value 1 and remaining point it is 0. So if we see like this is 0, this is 1 by n and then 2 by n. So in this interval 0 to 1 by n, what can be the functional value? It can be either 0 or 1. At point 0 it is 1, remaining point in this interval 0 to 1 by n, it will takes value 0. So what will be the upper bound in this interval? The functional value cannot go beyond 1, it can be maximum 1. So the upper bound is 1, even 2 is also upper bound, 3 is also upper bound. So what will be the supremum? Supremum is the least upper bound, least upper bound is 1. So 1 is the value of M1. Remaining interval it is 0 only. So all values are 0.
Remaining interval 0, how?
Similarly here because function value is 0. In each interval it is 0 remain, except the first interval it will take value 0. So maximum will also 0, even infimum will also 0. In the interval 1 by n to 2 by n, what will be the maximum value of this function?
0.
0. So if maximum is 0, that means upper bound will also 0, lower bound will also 0, infimum, supremum all will come 0 only. Here in this case,
So your voice is breaking.
Your voice
M1
is.
will, I'm lower bound value 0
Yes,
or now it is okay. So all supremum or infimum, whatever its upper bound cannot, means like all upper bound is greater than 1, all are upper bound. Less than 0, all are lower bound. So least upper bound is in this interval 0 to 1 by 1 by n is 1. Similarly, infimum. So this function has the integration value 0. If you integrate this function, you will get 0. Now come to the next question. Again we'll do the same thing. We'll find the supremum and infimum in each interval. So in this, again we'll take the same partition, 0, 1 by n, some n by n, n minus 1 by n. So what the function says that this is written 0 to 1 intersection with the rational number. That means when x is rational, it takes value 1 in this interval, and if x is irrational, it takes value 0. So function takes 1 if x is rational, it takes value 0 if it is irrational. So now by density property of real number, each interval, whatever interval you will choose, there
Yes, yes. You are muted, sir.
exists at least one rational, and there exists between there are rational number is also present. So in each interval, rational is also there and irrational is also there. So that means in each interval you will take function can take value either 1 or 0. Then what will be the supremum? Supremum will be 1 and infimum will be 0.
Zero.
Infimum will be 0. So now for this part C, if we calculate, this all will be, so this is part C now I am doing here, instead of 0, because in each interval rational and irrational both are present, so supremum will be 1 and here infimum all are 0. So this value will come 0, but this value will not come 0, it will come 1.
Non-integrable.
So this is not equal and it is not integrable function. That means we cannot integrate this function. Even if that function is not continuous, we cannot integrate this function. So the answer for this function is that this function is not Riemann integrable.
Sir, why you cannot integrate? 1 second, sir.
What?
Why we cannot integrate it? 1 second, sir. This is not
See, here-
continuous. I got it that thing. Hello.
Yeah, so this is acting. So for upper sum we need the supremum, for lower sum we need the infimum, because in each interval at least one rational is there, irrational is there. So in each interval it takes value either 1 or 0. Means both value are present in that interval. So what will be the supremum value? That is 1. Infimum value is 0.
Yes, sir.
So if you put supremum 1, so in each interval like m1, m2 all are 1, so you will get 1. This length is 1 by n. If you add you will get 1, but lower you will get 0. Both are not equal as n tends to infinity.
Yes, sir.
So both are not equal. That means this function is, and this is true for all whatever partition you will take, it is always 1 and that is always 0. Like, because whatever length here doesn't matter, it will always give 0 only. But this is non-zero. So that means this function is not integrable. That means we cannot integrate this function. So now this is another criteria, like epsilon criteria for the sequence. Sequence is convergent. For every epsilon positive there exists a natural number and we found a natural number. For continuity there exists a delta, we calculated delta. But in case of Riemann integrability, the upper sum and lower sum, this difference, because upper sum is always greater than lower sum, so we are not putting mod because it is always positive. That is less than epsilon. That means there exists a partition such that this is less than epsilon. So we have to find a partition such that this difference is less than epsilon. Then we'll say that function is Riemann integrable. Like in sequence, we have to find a natural number. For continuity and limit, we have to find a delta. So in this case, for every epsilon positive, we have to find a partition such that if this difference is less than epsilon, then we'll say that it is Riemann integrable. If it is not, or we are not able to find a partition such that it is less than epsilon, we'll say that it is not Riemann integrable. Is it clear? That definition. So like in the previous example, we have this is 1 and this is 0. This difference, upper Riemann sum and lower Riemann sum difference is always 1. So like if we apply this definition for previous example, then upper Riemann sum is 1, lower Riemann sum is this is always 1. So if we choose epsilon equal to half, or then it is not less than half. So we can, even whatever partition you will choose, it will always 1, that difference. So by this definition also we can say that that function is not Riemann integrable. So we have to check that the difference is less than epsilon for every epsilon positive. If there exists at least one epsilon, for that this property is not valid, then you will say that that is not Riemann integrable. So these are some results. For those function, no need to check anything. If function is continuous, that means it is integrable. You can always integrate a continuous function. Even function is not continuous, suppose function is bounded on this AB, or a function is continuous except few points, like only 2 point it is not continuous, or some 3 point it is not continuous, or some finitely many points if it is not continuous, then also that means it is discontinuous only finitely many points, then also function is Riemann integrable. That means we can integrate those function where the discontinuous.
Sir, you are muted.
Sir, you are not audible.
Then we can integrate.
So,
My voice is coming.
Yes, sir. Now it is coming.
yeah,
Yeah,
sir,
I'm
now
saying
yes,
that,
sir, now it's
and this whatever it is written here from A, B, C, those all are for this closed interval AB. Like if interval is changed, we are not claiming anything. For this closed interval, continuous function is always integrable. That is the limit from A to B. Similarly, any continuous function have some finite and discontinuity, then also it is integrable. And if it is monotone, that means it is either increasing or decreasing, then also we'll say that it is integrable. So some property of integration, like if you addition of two function, if you integrate, then you can break the addition, multiplication, substitution, integration by part, all those things how to integrate. So I am not discussing, and that is also not required for this course because you already know. So now this is the example. Can you do this example? That value of integration lies between this and this, 1 by 3 and 3 square root 2.
What we have to do?
So this is the example. Suppose you want to prove this, how you will do? So what is the integration of x square if it is 0 to 1?
1/3.
We have
1
1 by 3.
1 by 3.
So here 1 by 3 is present, 1 by 3 is there. So this 1 plus x we have to approximate something less than and something greater than. And it is very easy. So can we write this 1 plus x is always lies between 1 and 2? Or 1 and square root 2?
Yes, sir.
sir.
Yes, because x lies between 0 to 1. X cannot take value 5. In this range, x lies between 0 to 1. If you took minimum value, it will give 1. If you take maximum value 1, it will give root 2. So approximate this 1 by square root of 1 plus x from 1 and square root 2, you will get this result. After integrating this, because we know this is Riemann integrable. In the last class we have did this is 1 by 3. So this inequality is true. So this is first fundamental theorem of calculus, so I'm just recalling. If function is Riemann integrable from AB to R, and this capital Fx is the value of integration, because it is Riemann integrable from A to X, it will give some value, that is f of x. Then this capital F is continuous, and this derivative is nothing but f of x at some point x naught. That this, like this is antiderivative, or the f dash equal to small f. That is first fundamental theorem of calculus. Second one is that if you this antiderivative you will able to find, or you will able to integrate, then just apply the limit by fb minus fa, first upper limit minus lower limit, where capital F is the integration of this, or derivative of capital F is small f. So that anyway, integration by part, how to do substitution, all those things. So I'm not discussing like. Now this is the general setup of Riemann. We have seen upper sum and lower sum. So now we'll see Riemann sum. In upper sum, instead of this, we are taking supremum. In lower sum, we are taking infimum. But in Riemann sum, we can take at any point any value of this function at any point in this interval. So here this ci lies between xi minus xi. So you can choose any point, like middle point, you can choose xi, you can choose xi minus 1, any point in this interval you can choose, and you can multiply by functional value of that point, that is ci. and whatever sum you will get, that it's called Riemann. So remember the upper sum and lower sum. In upper sum, you can always take the supremum in this interval xi minus 1 to xi. But in lower sum, you can take infimum. But in Riemann sum, you can take upper sum, you can take lower sum, even you can take value at any point. There is no supremum or infimum is required. And this is the partition of the interval AB. So this is the more general setup than upper sum and lower sum, and that sum is called Riemann sum. It is denoted by S. Upper sum is denoted by U f comma p. Lower sum is L. So this is Riemann sum. It is denoted by S f comma p. That means it is f functional value in this interval xi minus 1 to xi at any point in this interval, including the boundary point also you can take. And here the same as the length of interval. So now by this definition, when you will say that the function is integrable, if function is bounded, it says it is Riemann integrable in this interval if and only if, means it is both side true, if this limit exists. So here it is written something. Can anyone tell what is the name of this and how to read this? These two lines, vertical lines, P or something, tends to 0. What does it mean? Can anyone tell the name of this? This two vertical line and in between something is written.
The mesh of partition.
Yeah, P is the partition, but what is this two lines? That is called the norm of P. We will read this in norm. So what is this norm? Will define. So norm of P means if you do the partition, it's not, it is exactly equal partition you did. So you will find the maximum length of the interval. Which interval have the maximum length? That is norm of P. And if that maximum length interval is going to 0, if this limit exists, then we will say that this function is Riemann integrable. So this norm P, if you put one line, then it is mod. If you put two lines, that is called norm. That is called the maximum length interval in partition P. Like suppose ith interval have maximum length you can calculate by xi minus 1 for ith length interval. So which one is the maximum, or in the mathematical term you can write like xi minus 1 this mod and take the maximum over I from 1 to n. So if I equal to 1, like x1 minus x0, then x2 minus x1. So this length, which one is the maximum length? That is norm of P. If that length is going to 0 and if this limit exists, we'll say it is Riemann integrable. And then this limit is nothing but the integration of a to b of the function f. So here it's not written properly. We can write fx dx. So now based on this is the question. We have to prove that this limit is equal to log 2. So how we'll do? So the question is that suppose this is the sequence and its limit is log 2.
So it is
Take
representing the
common
function or simple bracket.
What?
n, will take out n common.
N common.
Then 1 plus 1 by n, 1 plus 2 by n, it will come. That
Yes. 1 plus
So
1 by
it is
n.
simple bracket.
Yeah, this is the bracket. And then first term is 1 upon n plus 1, then 1 upon n plus 2. And the last term is 1 upon n plus n. That means 1 upon 2n last term.
So this one is written as summation of 1 upon n plus r.
Yes, we can write in the form of summation.
Yeah.
So this limit n tends to infinity. Whatever it is written, summation 1 upon n plus,
N plus r.
suppose r is running from
Yes,
1
sir.
to n.
yes, sir.
This one is changed as integration sign.
So now what we will do, we'll apply some definition that whatever Riemann sum, this, see here it is written limit of some partition, that means the maximum length of this, and this is nothing but this summation. So what we'll do, we'll relate this in the form of this, and once this is, then we'll apply this. That means this whole limit and this summation can be converted in the form of integration. So how we'll do later. First I will do some back calculation to just show you, and then I will tell how to do. Suppose the function is fx equal to 1 plus this one, 1 upon 1 plus x, and take the partition of equal length, that is 1 by n, 2 by n, n by n. So can you tell me what will be the Riemann sum in this case for this partition P? So this is the partition P. It will be summation. So Riemann sum says that the length of interval and the value of the function at any point in this interval. So suppose here C1 is here somewhere, C2 is here. So any point you can take, even you can take 0, even you can take 1 by n. So what I want to do, I want to convert something like this by using this function. So length of interval is 1 by n. So first I will write this f of ci. Ci we have to choose, and I from 1 to n. So f of ci is 1 upon 1 plus ci, because this is the function, and this is 1 by n, I from 1 to n. So I want this function. So what ci will choose, so that this whole thing will become this summation. What ci will choose, so that it will become
Sir,
the
R by N, R by
Take
N,
n common, sir.
R by
yeah,
N.
r by n.
R by
Then r by n equal to x.
Yes. So r by n we can take, so that it will become this. So here r is running from 1 to n, so that's why you are saying r by n. Here I is running from this, so we'll take I by n. So this ci will take I by n. If I equal to 1, it is 1 by n. That means we are taking this point. I equal to 2, we are taking this point 2 by n in this interval. That means we are calculating at this end point, the not left end point, we are calculating the value at right end point. Ci we can take anything. So this will exactly will become this type of, or it will exactly become this type of problem. So the partition limit, what is the length of this norm P in this case? The maximum length interval, because each in length is equal, that is 1 by n. So 1 by n goes to 0, that means n goes to infinity. In that case, this is exactly nothing but in the form of integration. Yes or no? So when length is going to 0, then this Riemann sum converging to this integral, that means a to b, that integration value is same as this limit. So that means this whole problem we can convert in the form of integration, and this is the function, this function we have to integrate. So I will directly write in the form of integral 1 by 1 plus x dx and some limit. So here this x is nothing but I by n or r by n, dx is nothing but this 1 by n. If we take this is x, then this is dx. So if you want to convert, so the general thing is that x is always I by n and dx is 1 by n. By using that, you can convert this in the form of integration. So now I will just write in the I, so there is no confusion. I. So by using these two, we'll convert in the form of integration. So here I by n is not there, 1 by n is not there, so just take 1 by n common, that will become dx, and then 1 plus I by n will become 1 plus x. I equal to 1, what will be the value of x? That is 1 by n. I equal to n, then the limit will be, these are the limit, I equal to 1 to n. So in this case, when I equal to 1, the limit will be 1 by n. I equal to n, that limit will become 1. So this side is 1, as n tends to infinity, this is 0. So now what is the integration of this? If you integrate, you will get ln 1 plus x. Now apply the limit from 0 to 1, that is nothing but log 2. So first write in the form of summation, and this summation you can convert in the form of integration by using these two convention, x equal to I by n and dx equal to 1 by n. Then it will become integration, then integrate it, you will get the value. Is it clear? So now next one is the improper integral. There are two type of improper integral. One is type 1 and one is type 2. When the limit of integration, these are definite integral. If the limit of integration is infinite, we'll say that integration is called improper integral. Or if integrand is unbounded in that interval, then also we'll say that it is improper integral. So for example, if we integrate like 0 to infinity e to the power x dx, so this is which type of improper, type 1 or type 2? So I'm giving some example. Can you tell me what is the type of? The first thing is that is it improper or not? Second one, if it is improper, it is type 1 or type 2. So like first one, integral limits are infinite here, so it is improper integral because this infinite. Because of this infinite, it is improper and it is type 1. This is finite, 1 is finite, so it is not type 1. But at x equal to 0, this is not defined, that integrand is unbounded, 1 by x is unbounded, so this is type 2. Here also at x equal to 1, it is unbounded, this is also type 2. So now we'll first see how to check that these are integrable or not. If it is integrable, then only we can find the integration. So like in the series, we have seen that sum is finite, so similar thing is here, that integral exists or not. That means these are Riemann integrable or not. So there are some problems which are both type. So can you give me example of integration which have type 1 and type 2 both?
Integration 1 to infinity 1 by x minus 1.
Integration 1 to infinity 1 by 1 minus x. So definitely that limit is infinite and this is also not bounded. So this is type 1 and type 2 both. It is improper integral. So this is the first result, or how you will solve that improper integral. That is called the convergence of type 1 improper integral. The type 1, that means that some limit is infinite, then you can put as a x and or some number, finite number, integrate it first and then apply the limit. So if f is Riemann integral, suppose f is Riemann integrable for all x greater than a, and if limit x tending to infinity a to x exists, that is same as a to infinity. Like if you put x equal to infinity, that value is converging to this value. That means a to infinity ft dt is same as x tending to infinity a to x ft dt. Suppose you want to solve anything which have the limit infinite, first solve for finite and then apply the limit. If this limit exists, that means this is equal to that integration. This is the first result. Exist means it should be finite integration, not infinite integration. If it is divergent, that means it has an infinite value, or it doesn't exist. That limit doesn't exist, or if it is exist, it is infinite also, then we will say it is divergent. So like for this question, similarly for minus infinity also we can define, minus infinity to plus infinity also we can define. So like suppose you want to integrate such type of this, then you can assume here a, then this is minus a, then a tends to infinity. First solve minus a to plus a and then apply a tends to infinity. Or you can break into this form like 0 to minus infinity to 0 plus 0 to infinity, and then also you can solve both. these are some example for type 1. So we'll solve this. So the first question is 1 upon t to the power p dt from 1 to infinity. We have to do this. Like what this is convergent or not. So this is the question we have to find. So for what we'll do, we'll apply something here. Like instead of this, we'll solve this problem. So this is dt. So we'll integrate this first. Once we'll get the integration, we'll apply limit x tend to infinity. If this limit exists, then only this is equal to this. Then we'll get the value of integration. So what is the integration of this? 1 upon t to the power p.
Power 1 minus p by 1 minus
T to the power 1
minus p upon
minus
1
p by
minus
1
p.
minus.
T to the power. So the value of integration is depends on p. Yes or no?
Yes, sir.
So t to the power minus p plus 1 I can write, but not always. This is valid only when
P is greater than 1.
if p equal to 1, then it is 1 upon t. That integration is ln t. Here it is even p is greater than 1. So for p greater than 1, this is the integration. Is it okay for p greater than 1? Because p equal to 1, it is 1 upon t. Even if it is for p greater than 1, now we'll apply the limit 1 to x. And then we'll put x tending to infinity. So what will be the... So first we'll apply upper limit and then lower limit by fundamental theorem of second fundamental theorem. Just apply the limit after integration. So it will give upper limit x to the power 1 minus p divided by 1 minus p, upper limit minus lower limit will apply, will get 1 upon 1 minus p. So now what will be the value as x tending to infinity? If p is greater than 1, then 1 minus p is less than 1. If we put x tending to infinity, what will be this term?
0.
0. So the
Zero.
value will come this p minus 1. So that means this integration, whatever it given 1 to infinity t to the power p, it will converge for p greater than 1. So now the second question. Minus infinity to infinity e to the power t dt. For that we'll take limit x tends to infinity minus x to plus x e to the power t dt. First we'll integrate, apply the limit and then x tending to infinity. So what is the integration of e to the power t? That will give e to the power t only. Apply the limit minus x to plus x. You will get e to the power x minus e to the power minus x. So what is value as x tending to infinity? Now we have to apply limit.
Infinity.
Infinite.
Infinity.
Infinity. So is this integration is convergent or not?
Divergent.
No sir. Divergent, because this is coming infinite. Now what about the part C? Do it yourself and tell me what will be the answer for C. It is convergent or not?
Convergent.
So what will be the value of integration?
Tan inverse t.
Yeah, tan inverse t. If you apply infinite, it will come pi by 2. So it is convergent. So now same as the series, if ft is less than gt and both are positive or equal to 0 also, then if the bigger integral will converge, then smaller will also converge like series. If G will converge, then F will also converge. But the converse is not true. Like if GT from A to infinity will converge, then F will also converge, similar like series. Then limit comparison, if you take the limit, then it will come L. If L equal to 0, then Ft converge only when if GT converge. If L is non-zero, then definitely both have the same property. Like if F is converge, then G will also converge. Similarly, if G will converge, then F will also converge. Like we are doing the series, the same thing here in the form of integration. So here it is written L. L should be finite. Like here L is non-zero, but L cannot be infinity. If L is infinity, then it will go to the reverse case of this. So this, because many people have this confusion, so here I am writing it is finite. The limit should be finite, because if it is coming infinite, that means GT by Ft is 0. That will go in this case. Like limit coming infinite means GT by Ft is 0. That reverse reciprocal will be 0. That means if G, that means the bottom one will converge, then upper will also converge. Like if G integral exists, then F will also exist. So how to choose the another, like there we are choosing some another function. So here how to, suppose we want to do something, then how to choose this function G, so that we can take this limit ratio and we can apply limit comparison test. So how we are doing in the series?
You check the degree of T.
Yeah, the same thing we'll do here, exactly same. So like for this function and this function, we have to check that. So one way you can integrate by assuming it is x and then x tending to infinity, and if you will get the finite number, you will say convergent. But instead of doing this, if you apply limit comparison or some comparison test, then also you can do. So the first one, like in series we are doing the same thing, we can do sin squared t dt. Can we write it is less than or equal to, after putting the maximum value of sin in the interval 1 to infinity. Can I write this? The maximum
Yes.
value of sin squared is 1. So this integral is convergent or not? It is 1 upon t to the power p. So this is kind of p series.
Convergence.
This is kind of p series, whatever we have seen. If p is
Yes.
greater than 1, it is convergent. But just remember, the limit should be 1 to infinity. If limit is something else, then we are not saying anything. So what G will choose here, so that we can apply some test here, like t square root of 1 plus t square. So this is convergent because we already did p equal to 1. So here p equal to 2, so it is convergent. So what G will choose for the part B? What is the G of t?
1 by t square.
Yeah, 1 upon t
1 by
square,
t square.
and then we'll apply limit ft by gt. If we apply limit comparison test, or you can take the comparison also. So what is this ratio? For limit comparison, we have to check that as t tends to infinity, what will be the limit? If it is coming finite, then both have the same nature. Like if this series, this integral will converge, then original integral will also converge. If it will diverge, then original will also diverge. So what will be the limit as t tends to
1 by
infinity?
square root of 1 plus 1.
1.
So it will come 1, which is not equal to 0, because of this integration of 1 to infinity gt is converging. That means this t square dt is converging. So original integral will also converge. So without integration, we can say that that integral have some finite number. That means convergence means it have some value, and that will be finite. So again, if it is absolutely convergent, that means if mod will converge, then original will also converge, exactly same like we did in the series. So like if we apply and mod, depending on the mod, if mod will converge, then original will converge. If original will not converge, but this mod will converge, then again the two division conditionally convergent and absolutely convergent. So same thing like series. So what about this question? It's convergent or not. So here it is written it is converges. That means you have to show that it is convergent. It has some finite value. So which test you? So how to show it is convergent?
Convergence.
Convergent.
It is less than 1 by t square.
1 by 1 plus t
So
square.
maximum value of cost is 1 and
Yes.
1 by t square is maximum
Yeah, maximum value it is
taken, and that we can see.
yes. So integral test is same as whatever we did in the series 1 to infinity to r positive decreasing function. Then this series and this integral have the same value. So this is not much useful here in this case. So it is not much useful if it is series. Then for series it is useful because this series is equivalent to this integration. If this integral will converge, then this series will converge, or reverse. If series will converge, then integral will also converge. So always just remember this I double f or if is written, then only one side true. I double f is written in both side true. Like here it is written I double f. That means if GT will converge, then FT will converge, or reverse. If FT will converge, then also GT will converge. Or if GT will diverge, then also FT will diverge. Or if FT will diverge, then GT will, because both sides it is true. But here it is reverse. It is written only if. If means if GT converge, then only you will say about FT will converge. Suppose if it is divergent, we cannot say anything about FT. So in this integral test, this is the last test for your syllabus. After that, this integral will finish. So what this I'm just quickly say, and you can try the problems later. So the function from a to infinity, g is also from a to infinity. The function is decreasing. Its limit is, and if this integration a to x gt dt, that mod is less than some finite number m, then this product will be convergent. This is called Dirichlet test. Like their root test, Rabi's test, ratio test, no more test. This is the last test in the integral. So you can apply this on this sin t and t. So here 1 upon t, if you take ft, gt equal to sin t. So 1 upon t means it is decreasing. 1 upon t limit is 0. Now we'll check that gt. So the first condition here for ft equal to 1 upon t and gt equal to sin t. So this result is for product. So the first condition saying that ft is decreasing, it is decreasing, and limit is 0, so it is satisfying for ft. Now the second one is for gt. So a to a value is 1, 1 to x. It is written 1 to x gt. Gt means sin t. Dt, and this mod is less than some number m. That means some finite number m will exist such that this mod is less than m. So what is the integration of sin x?
Minus cos t.
Minus cos t, and then apply the limit,
Minus
upper limit
cos t.
minus lower limit. So if we apply minus cos t upper limit and lower limit, it will come cos 1 minus cos x. So we can write this is less or equal to cos 1 plus cos x, and we know this sine and cos function always less than 1. So it is less than or equal to 2. This is m. So this condition is also satisfying. That means this integration ft into gt is also convergent by Dirichlet test. This also we'll discuss. No more, whatever we learn we'll apply. So here previous we have seen 1 upon t to the power p dt is convergent when p is greater than 1. Here it is written p is less than 1, but the difference is here it is from 0 to 1. It is type 2 integral. Previously it was 1 to infinity. So that we'll do in the next class.